In this video, you'll learn how to conduct a paired samples t-test in SPSS and calculate an appropriate effect size. A paired samples t-test is probably the best choice if you have one within subject's independent variable with two levels. You want to know whether one condition scores higher or lower than another condition in the same participants. The dependent variable is an interval or ratio measurement, and the data should also meet parametric assumptions such as normality and no influential outliers. For this example, we are going to use data from Mehr et al. They wanted to know whether melody could communicate social information. They told parents to sing a specific melody to their infant at home for 2 weeks. In the lab, the infant sat in front of a video screen showing two previously unseen actors. They measured how long the infant spent looking at each actor for the first measurement. Each actor then sang one song. One sang using a familiar melody the infants had heard at home, and the other sang using an unfamiliar melody. They then measured how long the infant spent looking at each actor for a second measurement. The dependent variable was expressed as the proportion of time spent looking at the actor who would sing the familiar melody. A value of 0 would be no time, and a value of 1 would be 100% of the time. In the following screencast, you will see how to conduct a paired samples t-test in SPSS using this data. To conduct the paired samples t-test, we need two columns of data. As we have a within subjects design, each participant is contributing one score for each condition. We have baseline gaze proportion and test gaze proportion. The first step is to explore the parametric assumptions, which we can simplify by focusing on the difference between each condition. For this, we need to compute a new variable. Click Transform and Compute New Variable. Create a new variable called something like gaze difference. Double-click on the baseline variable to drag it into the numeric expression area. Enter a minus sign and click on the test proportion gaze. Click OK to add the new variable to your dataset. We can explore all the assumptions using Analyze, Descriptive Statistics, and Explore. In the dependent list, we need to put our new variable gaze difference. Click on the plots options, untick stem and leaf, and click normality plots with tests, and click continue. Pressing OK will create the output. You'll receive a range of descriptive statistics and your plots for assessing normality. The first key output is the QQ plot. We'll break down the output later in the video, but for now, all of the dots fall tightly around the line, apart from one dot in the bottom left. You can ignore the detrended QQ plot as it shows the same information, just in a different way. Scrolling down, you will see a box plot of your difference score. The box looks nice and symmetrical, with 1 point again giving us something to think about. For the purposes of this test, we're going to leave the case in, but you could explore removing it to assess whether it affects your results. Now we are happy with the assumptions, it's time to conduct the paired samples t-test. Click Analyze, Compare Means, and Paired Samples t-test. We need to define the two levels of our variable, so drag baseline to variable 1, and test to variable 2. Options should be fine as default, so you can just click OK to receive the t-test output. This will add the t-test output below your box plot. You have the descriptive statistics, the correlation between conditions, which will be helpful for calculating an effect size later, and the results of the paired samples t-test. This is all the key information you need to report and interpret the t-test. We will now break down each component and demonstrate how you can report it in your work. To break down the output you received in SPSS, there are two key elements to check parametric assumptions. The first is normality, which can be assessed using the QQ plot. This shows the residuals all fall nicely along the line, but there is one point we could potentially explore further. The second element is the presence of any potential outliers. Here we can see the same point highlighted as in the QQ plot. It's a circle, which means it's between 1.5 and 3 times the interquartile range. This is a potential outlier, so we could explore removing it to see if it affects the conclusions we make. There does not appear to be anything else of concern though. Once you've conducted the paired samples t-test, the first part of the output is the descriptive statistics. We can see the mean proportion of gays is higher at test to baseline. It increases from 0.52 to 0.59. Further down, you have the t-test output. There are 3 key values to report: the t-statistic, the degrees of freedom, and the p-value. Here we can see the t-test is statistically significant. Referring back to the means, we know that mean gaze proportion was significantly higher at test in comparison to baseline. The t-test is one component, but we also need a measure of effect size. We have 2 options here. In the t-test output, we could report the unstandardized mean difference and its 95% confidence interval. This is the best choice if the units are logical and consistent across studies. We can see that gaze proportion increased 0.07 units from baseline to test, which means the infant spent 7% longer on average looking at the familiar melody actor. Alternatively, we could report the standardized mean difference, also known as Cohen's d. The easiest way to do this is through the psychometrica.de website, as you also receive a 95% confidence interval. You will need to enter the mean and standard deviation for each condition, and the correlation between them. SPSS version 25 or later reports this in the output, and should be 0.546 for this dataset. This provides a Cohen's d value of 0.41, which is approximately a moderate effect size. To report the results of your paired samples t-test, you will need the t-statistic, the degrees of freedom, the p-value, and your choice of effect size. For example, we could say, a paired samples t-test showed that the proportion of gaze towards the actor who sang the familiar song significantly increased from baseline to test.